technically this lesson was, the 2 lessons that I do today were supposed to be the 2 lessons for day 3. So both of them say day 3. Today's will be fine. Okay, so we're going to start off with solving quadratics. So yesterday we solved quadratics also. You guys would do the asterisk and we would solve that way. Not every single quadratic can be factored. It's a little bit easier just to use the asterisk. But every once in a while, you guys will run into quadratics that the asterisk just won't work. So it works all the time. So even the ones we did yesterday, we could have used the quadratic formula on and it would work. I prefer work just because it's faster. But today we're going to do quadratic formula for just in case you guys run into one that can't be factored. And when you whether to factor like we did yesterday or to use the quadratic formula, and you'll have to do it the way that it says. Okay? We've all seen this before. Well, it is on your blue sheet, so you don't have to have it memorized. The more you keep writing it out, the more you just end up remembering it anyway. But it is on the reference sheet. It's at the top. So before we do the entire quadratic formula, we're going to talk about what we call the discriminant. It's just this piece that's under the big radical. So whenever you guys write this out, remember anything put in parentheses. Remember that? I told you that yesterday. Anytime you square a number, make sure the number's in parentheses. B squared minus 4 times A times C. That is the part we're going to focus on first. The solutions the quadratic is going to have. It'll tell you if there's only going to be one solution. It'll tell you if there's going to be 2. And we're going to focus on first. Okay, so down here at the bottom, it says, it shows the entire quadratic formula. Will describe the nature of the roots. So it tells you whether there's one solution, 2 real solutions. First, here's the discriminant yet again. I'm just going to throw those parentheses in there. Because where those parentheses are, we're going to actually plug in 3 numbers. We're going to plug in the value of B, the value of A, and the value of C. All right, go ahead and turn the page so we can actually practice. Yes, you should have done them a little bit in 1B. Here's our quadratic. And these are the 3 different types of situations. So even yesterday on your notes, we talked about if the parabola crosses twice, 2 real solutions. If it only crosses the x-axis once, there's 1 real solution. And then we talked about what if there were no real solutions, which means there are 2 imaginary solutions. Okay, now the way to figure that out, I'm going to have the quadratic formula. The way to figure it out is we're going to plug our numbers into the discriminant. So we're going to plug it into b squared minus 4ac. We're going to do that on the calculator. And if your answer is your discriminant, you type it into the calculator, and a negative answer pops up, you will tell me that there are 2 imaginary solutions. Okay? So if the number under the radical is negative, the x-axis at all. And if it doesn't cross here, there are no real solutions. They're both imaginary. Okay? If you type and you get an answer of 0 that pops up on your calculator, that means there is only one real solution. So an answer of 0 means there's one real solution. Now the 0 would be under the radical. What's the square root of 0? 0. And in the quadratic formula, there's a plus and a minus sign in front of it. Wouldn't you get the same thing if you subtracted 0 from it? Yeah, so anytime you have an answer of 0, there's only one real solution. Because if the number under the radical is negative, so like, let's just say negative 25, pick up your calculators. I need you to hit, I don't know if you guys know how to type in square roots, but it's the second button. Second x squared. Type in that, a radical pops up, and then type in negative 25. What that means is you cannot take square roots of negatives, because think about it. The square root of a number is the number times itself that times negative 5 would give you positive 25, not negative 25. So negative numbers don't have real, okay? That's why if your answer is negative, it's two imaginary solutions, okay? If your answer on any positive number, then you will have two real solutions. Okay, so think about it. What is the square root of 16? 4. And in the quadratic formula, there'd be a plus and a minus in front of it. Is it bigger than if I subtracted 4? They'd give me two different answers, right? Yeah. So we would get two different answers. All right, go down here to the bottom. We're going to practice this. Even when you're only dealing with discriminant, the quadratic, this one's already set equal to 0. So here's A, right? The 3 is A, B is negative 11, and C is. So when we do the discriminant, this is all you guys have to write out. We're going to put negative 11. What's A? 3 and C. So you're just plugging this into B squared minus 4AC. Once you write this out, type the whole thing into your calculator at once. Is not the same as this button. This is the negative button. This is the minus button. Do not use the same button. Are you getting an answer of 1? Okay, so if I said, if the directions on your paper simply, let's just say it said this, find the discriminant. My discriminant is 1, okay? But there is a second. The second part to this question says, what type of solutions? Well, is this 0, positive, negative? Answer. What type of solutions do we have? 2 real solutions. Yep. nice practice today on the front of your practice page. They are going to ask you just to find the discriminant. They're going to ask you to find the type of solutions are they based on the discriminant. Okay? Is this supposed to be number 2? I don't know. Okay, so for number 2, is it already set equal to 0? Yes. So now we can just go ahead and go straight to times A times C. What is the value of B? 2? Yep. So A, B, C. Okay, once you have that on your paper, then it just negative 252. Now type it in. Do you get that? And whenever we have a negative number under the radical, what's the type of solution? Imaginary solutions. Are going to be either 1 real, 2 real, or 2 imaginary. Okay? Every time. Now, I'm abbreviating here. I put IMAG out. You don't have to write everything out. I do the same thing because I always abbreviate POS for positive too. All kinds of fun acronyms in math that mean multiple things. If you get a positive answer, it's 2 real, negative, it's 2 imaginary. The only one we didn't do is if you get an answer of 0. So like if we had typed this, okay, those are the only 3 options you have. All right, flip it over. Now we're going to get into the quadratic. Every single number under the radical would be a perfect square. Remember those numbers on your factor sheet that have the stars? Those are your perfect squares. Do you see them all? Okay. Well, these obviously are not perfect squares. So, I know you guys did this last term. You will have to simplify the number under the radical. So, before I start this, look at 53. Like, let's just pretend that under the radical, you guys had a 53. Does it have, like, what's the factor pair? It's just 1 times 53. Does that break this down at all? It doesn't change. However, if you have a number like 72, look at the row of 72. Hang on, I'm trying to do math in my head. Hang on. I'm like trying to concentrate. Okay. Here all my thing, I'm gonna tell you the easiest way to do this. We are going to make a factor tree to break down if it breaks down. Now you have to be very particular about how you break it down. You want to find, so like for instance, that has a perfect square, this has a perfect square, and so does this one, right? Oh wait, I'm missing something. What am I missing? Here it is. I didn't circle it. We have this one too. There are actually 4 options that all contain at least. I could use 8 and 9. I could use 4 and 18. And I could use 2 and 36. 1 and 72 wouldn't help me. What you to do is to use the biggest one. So we have 4, 9, and 36. Which one's the biggest? So I would write 36 times 2. Okay. Which one of those is my perfect square? Please. Now we are ready to write our answer. The square root of this gets to come out of the radical because we know the square root of 36 is, so 6 comes out. Do we know the square root of 2? The 2 a perfect square? So where's the 2 stay? Stays under the radical. Do me a favor. Everyone type in square root of 72 on your paper, or on your calculator. Type it in. And what are you getting? Just 8 point, and it goes on forever. Type in 6, then hit the square root, so do second x squared, and then 2, hit equals. Okay, that is a way to check yourself. So when you actually have your final answer, type that in and the original and make sure they match. Now the reason I want you guys to look up here, please. The reason I told you to pick the 36 and 2 I want to show you what happens if you don't use the biggest perfect square unless you want to. Let's just say when I think of 72, the first thing that comes to mind, I'm struggling this afternoon, is 8 and 9. So that number can stop right where it's at. Can I still break up 8 into what? Perfect square? Okay, so here's the thing. The more branches you have on your factor tree, the harder it is. Here I only had to do 2 branches. Here I just had to do 4. Now, can I still get the same answer? Yes, because watch. Square root of 9 is 2. 6 comes out, and then that 2 still stays under. So it is still possible to do it that way. But pair rather than pick this pair, because then this pair had to be broken down again. So I always tell everyone, make sure when you find the biggest perfect square that goes into that number. It's just going to make your life a whole lot easier. On your factor sheet. However, when you see something that ends in 0, what number do you know it's divisible by? 10. And when you divide something by 10, all it does is knock off a 0. So what's left? 6. Listen, I don't expect you guys to necessarily have that thought process, but what you guys would do is you would start dividing by perfect squares. So like you would do 160 divided by 100. Well, it's a decimal, so that's not going to work. 160 work. 160 divided by 64 doesn't work. And you literally, let me borrow your blue sheet. You are literally just, you want to make sure you start with the biggest one because you have to find the biggest one that works. So I tried these, they don't work. I get to 4, didn't work, 25 didn't work. Then all of a sudden, if I type in 160 divided by 16, it works. It gives me a whole number of 10. So does that make sense? Okay. Could I break down the number 10? But are either of those perfect squares? So it doesn't help us to break it down. Okay, the only time you want to break it down is if it can break down to a perfect square like this one over here did. What's the square root of 16? 4 comes out. What stays in? 10. Square. So you take the square root of it and you bring it out. And then this number that you don't know the square root of, it just stays under the radical.
No matter which side we put the 10 or the 16 on, that's one of them, me and my sides.
Multiplication, remember, order doesn't matter.
Okay.
So the only thing I see some people do is they put a 16 out here instead of a 4 because they're thinking this number, but it's not. This is under the radical, so you'd have to take the square root of it. Now this is preparing you for the big quadratic formula because if the number under here and take a factor tree and you're going to have to break it down. Yay. It's fun. Okay, turn the page. Well, now we have to do the entire quadratic formula. And I am very particular about what I'm going to ask you to show. So I don't like doing it the way they did it. So we're just going to do this whole thing. But tell me, is this already set equal to 0? Yes. So we are ready to just identify A, B, and C. So A is B, -6, and C, 8. So since there was no number in front of x squared, it's a 1. For the whole thing. Go ahead and write x equals. Okay, now, formulas you have to have it memorized, but if you don't know how to use the formula, it doesn't help you. Okay, so we need to talk, this is always going to be in front of you. This is negative b, all that means is the opposite of whatever b starts out as. So currently b is this, so what would I put here? Then you're supposed to put the plus and the minus symbol. Then you guys are going to have a big radical. This radical is, look up here, the discriminant. So this is where we're going to plug in the b squared minus 4 times. So I always like to just get that set up and then I just start plugging in my numbers. So B, the original. Okay, so will these two ever match each other? No. This is the original, this is the opposite. 1 and C goes here. 8. Okay? That's the entire, look up here. One big fraction bar under the whole thing. going all the way back to here, you guys. All the way back to the 6. One big fraction, 2 times A. And what was A? 1. Okay. I always want to see that. Do is show me substitution. So I want to see the entire quadratic formula with all your numbers plugged in. Okay, the second thing, the plus minus, but we're going to shorten up that radical sign. We're going to make it much smaller. We're going to go ahead and multiply the bottom, which the bottom is just 2 times something. So you guys should always be able to just do that in your head for the most part. What's 2 times 1? 2. We're going to do the discriminant. Okay, so what we were practicing before, I don't want you to put the radical sign in the calculator. So you need to type that in, and whatever you get for your answer, you're going to put under. So type in what's under the radical. Type it in. Make sure you're getting the number 4. Is not going to be a perfect square, and sometimes it's not going to even be that small. That is not a minus sign. Right. So change that to a minus. Just hit the minus button. Then hit equal. Okay. So what you should do at this point, because let's just say this was like 400. Do you know if 400? What you should do at this point is you should always type this into the calculator to see if it's a perfect square. So obviously we all know 2. If you type in the square root of 4 on your calculator, it's just going to become a whole number 2. So if it's a perfect square, you already know what the square root is. All you're going to do is this. You're going to drop that radical sign, and you're just going to make this the same. The square root of 4 is 2. So the radical disappears. And because there is no radical sign left, we now can get our 2 individual. Radical is positive. Shouldn't we get 2 answers? 2 real ones? Yep. So how do we get our 2 answers? 6 plus 2 divided by 2. And then we're going to do 6 minus 2 divided by 2. Was 6 plus 2? And 8 divided by 2? Was 4. So I tend to go back and do my subtraction one. That's why that plus minus sign is there, because you're going to add and then you're going to subtract. What's 6 minus by 2 is 2. So there are our 2 answers to this problem. Those are the 2 solutions to this quadratic. Now this one, actually, you could have done a factor tree for the, factor tree. You could have done an asterisk for this problem. I am. Thanks, Caleb. I am off my game big time. I wasn't this morning. Thanks. Thanks for pointing that one out. I know. But I don't even remember what I was saying. Oh, we could have used the asterisk, but because they told us to use the quadratic formula, that's what we had to do. Okay?
You're just doing it in a different way than I did.
I don't think it could have been that different than what he did. There's really not many different ways for you to do the quadratic formula.
No, but like, he didn't, like, I guess he didn't break down the.
Well,
radical.
you only get to do that if it's a perfect square. So this does not happen that often. You're going to get a lot of problems where the number under the radical is not a perfect square and you have to make a factor tree. This one just happened to work out nice. The other ones we do, they're not going to be that nice. No, we're never going to write it as a decimal. Yeah. So in the past, whatever was under here, if it wasn't a perfect square, you could turn it into a decimal. We don't do that anymore. We do the simplifying the radicals, like we do the factor trees. All right. How do you guys feel about that first one? Is it okay? Okay. Well, you get lots of quadratic formula today. Okay, so now take a look at this one at the bottom. Because this one, there's already an issue right off the bat. It doesn't equal 0. Now, a couple of you yesterday, I know why you wanted to do this. There's only one term on this side and there's 2 terms on this side. Some of you yesterday wanted to take this one and move it over. And just because it's less work. However, quadratic formula is way easier if you leave the x squared term positive. So I will never move this. And if that had said negative 5x squared, I'd move it. But because it's positive right now, I want these two to come over here. Okay? And to bring them over, they become their opposites, don't they? Like the 2x, wouldn't I add 2x to get rid of it? Okay, so I'd add 2x over here. How would I get rid of a positive 6? I'd subtract 6. So now this side, everything's gone. Tell me about that left side. Do any of those terms combine? No. But I have to put them in the correct order, right? Which one has to go first? The 5x squared. Which one has to be in the middle? The 2x. And which one has to go last? The minus 6. It has to go x squared, x constant, because this is A, B, C. If you put these the other way, you're going to have the wrong B and C, because you're going to have B as negative 6 and you're going to have C as 2. And then the whole thing's going to be wrong. So you need to make sure if you have to move stuff over, get it in the right spot. Okay? Let's identify A, B, C. Y'all need to get some whiteout tape. It is the best. My favorite. So yeah, A is 5. B is 2, and C is negative 6. And then the first thing we're going to do is we're going to plug in, we're going to do that big substitution step. I like to set this stuff up with all the blanks, because then I can just go in and fill numbers in. You don't have to do that. You can just do it as you go. I've been doing this stuff a long time, so I like to have it set up for me. Okay, so again, the very first number that you put here is the opposite of B, not original B, opposite of B. So what goes first? Negative 2 plus or minus, and then big radical. because then under the radical, we have to do b squared minus 4ac. So original b, 2. So I have 2 in parentheses squared, minus 4, parentheses, what number goes? 5. And then the second set of parentheses would be c, which is negative 6. And then on, so again, big fraction bar under the whole thing. And then 2 times, no, 2 times a. A is not 2. A was 5. 2 times 5. So that's just the substitution step. So in your next step, this is what you guys are going to do. Everything that I highlight, you will put into the calculator. So you'll do what's under the radical, but and then the denominator, we can do the 2 times 5 in our head. But the negative 2 comes down, the plus minus comes down, and we just shorten up the radical. Because we're going to actually figure out the number that goes there, and 2 times 5 is 10. So then you need to type in the green stuff, the discriminant. $124. 124? Is that what it is?
I did something wrong. I got 34. No, I did something wrong.
Oh, I know. You left off the 4.
So where do we add the
Just
2
2
times 5?
squared. You're not doing that.
Not yet?
Mm-mm.
Okay.
You're just doing the discriminant. Is everybody getting 124?
Oh, yeah, that was wrong.
You should get 124 there.
Oh, I see it. Okay.
And then on the bottom, the 2 times 5, you can use the calculator. I just assume most of you know what 2 times 5 is, which is 10. Maybe.
The jury's out on that one.
Mm-hmm. All right, so now here comes the extra fun stuff here. Okay, so now your factor sheet only goes up to 100. So what should you do at this very moment? What should you be typing into the calculator? We don't know if 124 is a perfect square, so how do we find out? Yep, take the square root of 124 on your calculator. Just do it. Most people don't have that one.
Oh.
Most people stop at 100. So right now in your calculator, type in square root 124.
It's a decimal.
Okay, it's a decimal. So it's not a perfect square, so I don't get to drop the radical like we did before with the number 4. So instead, here comes the fun part. We have to make a factor tree. We have to break down 124 into a pair of numbers where one of them is a perfect square. Okay? So if it were me, let me just show you. Okay? Now again, I don't know. It's going to vary from person to person. I don't know how many of you guys would know that 124 off the top of your head is not divisible by 100. Well, it would have to end in 2 zeros. So I'm not going to try 100, but like I might start with like 124 divided by 81. I get a decimal, so clearly it's not 81. That's 9. So then 8 is 64. See how it's still a decimal? So it's not 64. Then I would try 49. Still a decimal. Now listen, I get that this is taking a while, but this is what it is. 36 doesn't work. What is that? 6. 25 doesn't work. 16 does not work. 9? Nope. So it better be 4. Now here's the thing. Sometimes, because I tell you to start with the biggest perfect square and work your way down, because you always want the biggest one that works. Well, unfortunately, sometimes 4 is the biggest one that works, but you won't know until you start typing them in. So I get that that took a minute, but I mean, too bad. You just have to do it anyway. So 4 times 31 is my factor pair. So you have that, but not everybody in here has that. So you could have just looked at that and you would have used 4 and 31.
No.
Why? 4 is a
I
perfect
would-
square.
See, I would use 2 and 62.
But neither of those are perfect squares.
Oh, see,
You
I
have to
did
pick a
wrong.
pair that has a perfect square.
Yeah, I would do
So
wrong.
it has to be this one because 4 is a perfect square. And then 31 doesn't break down anymore.
Okay.
So we're ready to write this as the simplified answer. What's the square root of 4? 2 comes out. What stays in? The 31. So this right here, this is going to replace this. So square root of 124 simplified to this. So I'm going to write it right here. We just simplified it. So that goes there. Now you would be done right now. Okay, just hang on. You would be done for the most part, because if there's still a radical in your answer, I don't make you go through and do the addition and do the subtraction. The only time you have to go through and do the addition and subtraction is if our radical disappeared. Most of the time it doesn't disappear. So you get to leave your answer in that form. I can see 2 answers. I see the plus and the minus. However, you have to look at these 3 numbers right here. If all 3 of those have something in common, you have to reduce, because it's like a fraction, right? I mean, it is. It's not like 1. It is 1. What are 2, 2, and 10 all divisible by? 2. So all you guys have to do is now divide those 3 numbers by 2. The 31 is not allowed to be touched because it's protected by the square root sign. I like that. It's under the square root, so it can't be touched. Okay, so these are all going to be divided by 2. Just cut them in half. Leave the 31 alone. There's your final answer. So that would be read as -1 plus or minus 1 square root of 31 divided by 5. Nobody said Algebra 2 was going to be easy. I still think overall, Algebra 2, it's not like each individual concept is that difficult. It's just there's a lot of steps. A lot of steps. The further along you get in math, it just keeps using the same stuff over and over again, but instead of having just like one thing per problem, you might have 4 different standards you've covered in one problem. So they do get longer. But the process of quadratic formula never changes. So everything we just did there, it's the same steps over and over and over again. The only thing that changes are the numbers. That's fine. Yes. We'll talk about that later. That probably just picked me up. That's fine. No big deal. All right, you good? Ish? Good-ish? Okay, turn the page. We're going to do one more together. What'd you just say?
And right together.
Yes, together. We like doing things together. I do. I don't like doing things alone. Okay, tell me about that quadratic. What has to happen? We just have to move the 11. We only have to move one term this time. This 11 needs to come over here and join up with everything else. Is that 11 going to pair up with anything else though?
No.
No? So we just have to make sure we put it in the correct order. So 2x squared plus 8x minus 11. Okay, what is A? 2, B, and C? Negative 11. I'm setting it up. I'm not putting any numbers in except for the ones that we know. I'm just leaving everything blank. All right, you guys ready to plug these numbers in? Oh, good. Then the opposite of B. Okay, regular B, regular A, and C. And A on the bottom. See? Piece of cake. That's just substitution. That's just plugging them in. So now we get to actually do the computation. So now I'm going to bring down my negative 8, the plus minus, and I'm going to shorten up that radical sign. And then I'm going to go ahead and multiply the bottom out. 2 times 2 is 4. So the only thing you typically have to worry about typing into the calculator is the b squared minus 4ac. Hmm, 6488. Yep. Should be 152. Is everybody getting 152? Well, make sure you're getting 152 because that's what it is. Okay, so then, you know, if this number right here were 52, look at your factor sheet. Look at the row of 52. I'm just making this up. Just look at 52. Not 152. Look at 52. Does 52 break down to any perfect squares? No, because it's just 2 and 26, right? And what else? Oh, wow, that was a horrible number. That's not the number I wanted you to look at. Look at 55. Let's just pretend like this number right here was a 55. Does 55 break down any perfect squares? No. So if this were, hope you're listening, if this were 55 and it doesn't break down at all, you would be done. You wouldn't have to do anything else because 55 doesn't break down and it's not a perfect square. So you would leave it. With a number like 152, check and see if it's a perfect square. So type in square root of 152. It's not. So guess what? We get to make a factor tree. Now, we all understand my process that I showed you on the calculator, right? Because I'm gonna go ahead and tell you what number it is, but we understand what we would do. 152 divided by 100, 152 divided by 81, and you would work your way down that list. Guess what number is the biggest perfect square this time? Guess. It's 4 again.
Then we have to
4.
divide by the whole factor sheet. That would take forever.
Well, no, you want to start, you're just going to use, most of the time, you're going to just use the ones that I have marked on there.
I know, but I'm just saying, if we had to use the whole factor sheet, like, that would take forever.
Yeah. I mean, yes. But when you
Just
guys,
those numbers
when you
take
try to
forever,
break it
so-
down, you want to use these. Those are the ones that you're typically going to use. And I just want you to start up here, because if you guys start here and you work your way up, if 4, 16, and 64 work, but you use the 4, you're going to have lots of branches, and then it's just going to be confusing. So I always want you to go top down, okay? It's just this one again, 4 was the biggest, which was 38. 38?
Those aren't on here, are they?
I don't think yours goes up to 152.
So those are the ones to try that you just wrote on there?
Yep. Well, they're marked on yours. The stars. The stars are the numbers. Ah! No. The stars are the ones that I just wrote up on the board. Those are all your perfect squares.
No, I mean the ones to try to punch in to try.
Are the ones with the stars.
Oh. To divide by.
Yes.
Okay.
All right, so it's 4 times 38. So what is the square root of 4? 2 comes out, 38 stays in. Now listen, if you look at your factor sheet at 38, it breaks down to 2 times 19, but those aren't perfect squares, so you don't break it down. You just leave it like this, and we're going to take this.
We break the other number down if it's a perfect.
Yes, but if you use my method, if you use the biggest perfect square, the other number should not break down. Okay? That's why I teach it that way. So I'm going to take the square root of 152 out, and I'm going to replace it with what we just found, the 2 square root of 38, and then the bottom stays a 4. So you would be done right now
But
if, well, sometimes it won't reduce, sometimes it won't, but you always have to double check, like you're going to always have to look at those 3 numbers right there, because if they reduce, you have to reduce them. Now listen, I am thrilled if you can get to this part. If the only thing you forget is the reducing, I will remind you of that. But if you can get here on your own, that's great. Like you've done all the hard stuff. This last part, what's 8, 2, and 4 divisible by? 2. So just cut them all in half. Not the 38, leave the 38 alone, but divide everything else by 2, and then you're done. You don't have to separate it. The only time you separate it is if the radical sign disappears. That's the end of lesson 1.